Hello! We're getting started! Hooray! So, in this situation, you've gone to Mars. And you didn't want to go alone. Now, you have to be awake and everything going on thing, but your pet, you want your pet to come back here with you, right? Because you wouldn't want to be alone on Mars. So you've had to bring your pet there frozen in liquid nitrogen. Liquid nitrogen is really, really cold. So you have your poor pet, which is frozen. That's why I'm drawing in blue. And you need to thaw your pet out so that you can revive your pet. Seems like a good plan, right? So, there's a couple things to think about this. You need to get your pet from negative 196 degrees Celsius all the way up to body temperature. But it's not that simple because your pet is frozen. And then your pet needs to be thawed. So, if you started heating it, the temperature would go from negative 196, it would go up until it got to 0. But at 0, that's when your pet starts thawing out. So you're putting heat in, but the temperature doesn't go up. But then, once it does, you'd very quickly get up to 37 degrees, which is body temperature, and voila, Charlotte is saved. So, how are we going to do it? The thing you got to think about is there are basically 3 parts of this problem. You've got the ice part, where you're heating it up. You've got the transition, and then you've got the part where you're heating it up to body temperature, and you're going to be good. So the first thing you got to do is, this is the specific heat when you're solid, frozen solid. That's supposed to be an ice cube. The transition heat, which is the latent heat, plus you're going to need the specific heat as a liquid. Okay? So, solid, liquid. Those are horrible pictures, aren't they? Anyway, the math will be top quality. So, for the first part, you're going through your transition, so it is your mass times the specific heat capacity times the change in temperature. For the latent heat, it is your latent heat, which is, I guess, I don't know how do they abbreviate that? Who knows? I'll just keep using LH times the mass. And then for the last one, it's the mass times the specific heat. This is a different specific heat for water. It's not the same for ice as for water. Times the change in temperature to go from 0 to 37. So, mass of the chicken, in my case it's a chicken, 3.2, times the specific heat of ice. Now the specific heat of ice is less than it is for liquid water. It's 2090 times the change in temperature. Going from 196 to 0 is an increase of, going from negative 196 to 0 is an increase of, 0 minus 190, negative 196. Well, it's 196. 196 degrees, right? Plus the latent heat. The latent heat, the amount of energy required to thaw out 1 kilogram of water, is big. It's 333,000 joules for every kilogram, and my chicken is 3.2 kilograms. Plus the amount of energy needed to heat up the rest of the way. So the chicken's weight still stays the same, times the specific heat of water, one of the few numbers I expect you to remember, 4186, times the change in temperature. 0 to 37 degrees is an increase of 37 degrees. Wow, that's big. But let's just do it. Okay, so how much energy does it take to go from negative 196 to 0? If you put it in a calculator, and I highly recommend you do it, you get 1,310,848 joules. Don't worry about rounding it. We're round at the end, you know. Plus, the amount of energy needed to thaw your poor chicken out is 106.65 1,065,600 joules. Now, these are all in joules. And then finally, the amount of energy to get your now thawed chicken up to body temperature. I do hope chicken body temperature is the same as human body temperature. What could go wrong? So I'm going to multiply that. And now this is, now you may notice the specific heat of water is double what it is for ice. But in this case, you're not making as big of a rise. 0 to 37 is a very small increase, whereas that's a big increase. So it's not surprising we get the smallest number we've had to deal with yet, 495,622. And then it's just addition. You add it up, I got 2,872,070. Now, by the way, how do you round? Are we sure it's exactly this amount? No. We do have limits here. 2 sig figs, 2 sig figs, 2 sig figs. So really, you can't go any further than here. So we're going to have to round this up, and we're going to get a total of 2,900,000 joules, or if you prefer, 2.9 megajoules. Now, by the way, is this a lot? Well, no. When you think about it, I burn through 13 megajoules every day. This is a lot less than that. I mean, the amount of energy that I use in a day, the amount of energy you use in a day is many times more than what you would need. But I think I could thaw her with love. Now, something to think about. If your pet is not a chicken, your number is going to be different. If your pet is bigger, expect your number to be bigger. If your pet is 10 times the size, expect that your number is probably going to be 10 times the size. If your pet's 100 times the size, God knows what that could be. It could be a horse or something like that. Expect your number to be 100 times the size. So it's not necessarily going to be the same for everybody, but you got a pretty good idea how to do this, and that's the most important thing.